Hi, I Aziz welcome you to CoedMaster, and in this video I am going to talk about this problem. So let's get started. So the problem is given is you are given a number n and your task is to find if the given number is lucky or not. So it means let's say you have a sequence of number from 1 to n and you have to find if the nth number is lucky or not, right? Okay Aziz, we understood that we have to find that if Okay Aziz, we understood that we have to find that if a given number is lucky or not. But could you please tell us that how to define lucky number? So here is the process of arriving at lucky number. So to find the lucky number, we have to follow this process. And what is the process? So say we have a sequence of number from 1 to n. So in first step, we delete all the second number. And after deleting second number, you are left with remaining numbers, right? So after second step, your task is to delete all the third number. And after third number gets deleted, you are left with some numbers, right? And after third number gets deleted, the third step is to delete all the fourth numbers. And after deleting fourth number, you are left with the remaining number. And you have to continue this process indefinitely. So it means a number is said to be a lucky number if it does not get deleted due to the above process, right? So you have to follow entire process and you reach at the state where you could say that this is the lucky number. And how you decide that is how you decide if that number is lucky or not? You simply check if that number doesn't deleted due to above process, then it means it is a lucky number. Okay. So just to give you a clear picture, let's see with an example. So let's say the number is 10 and this is a sequence from 1 to 10. So what happens? In first step, we delete all the second number. So it means we are going to delete 2, 4, 6, 8 and 10. Now you can see that the 10th number is gone. It means 10 is not a lucky number because in the first step only the 10 gets deleted, right? So let's move on to next example. So in next example, the number is 19. Okay, so let's repeat the same process. First, we are going to delete second number. So second is deleted. 4, 6, 8, 10, 12, 14, 16, 18 and 20. So all the second numbers are deleted. Now we are left with all the remaining numbers. Now in second step, what we do? We simply delete all the third elements. Okay, so let's delete third number, that is 5, 11 and 17. And now we are left with these many numbers. Okay, in next step, we have to delete fourth element. So let's delete fourth element, 1, 2, 3, 4. And that's it, because now we are left with only 3 elements. So we do not have fourth one to delete. So now we are left with all these numbers. Now let's delete fifth element. 1, 2, 3, 4, 5. So 15 is gone. Now we are left with 1, 2, 3, 4, only 5 numbers. So we are left with only 5 numbers, you can say. And in next step, we have to delete sixth number. So at this point, we have to stop. Why? At this step, we want to delete sixth number, but we only have 5 numbers, right? So here we have to stop. And you can clearly see that our 19 is a lucky number because 19 is at the safe position. So we can say that the 19 number is lucky and the output of this input is going to be true. Okay, cool. So now you have clear picture about how to arrive at lucky number, right? So let's pause this video for a while and think about a solution to solve this problem. Okay, so on the left side of the screen, you see the simple implementation to solve this problem. And in this implementation, we have written a function is lucky number and this function is taking 2 inputs. One is n and second is the divisor. Divisor is nothing but a number that is to be deleted. It means if the divisor is 2, it means all the second term has to be deleted. If the divisor is 3, means all the third term has to be deleted, right? So in the first step, what we are doing, we are simply checking if n is divisible by divisor or not. It means if we have a number, let's say 1, 2, 3, 4, 5, 6 and if divisor is 2, it means we have to delete all these second term. It means 2 is gone, 4 is gone and 6 is gone. Okay, so if n is 6, and divisor is 2, it means the sixth term is gone. So in first step we simply returns false. Okay, so in first step we simply find that the sixth number is not a lucky number, because in the first step only it gets deleted, right? Let's say if n is 5, then what happens? If divisor is 2, then delete the second term. After deleting second term, we are left with only 3 terms, 1, 2 and 3. So we move on to next step. And what is the next step? Divisor is greater than n. So this is a condition where we have to stop, and we saw this in example, right? Let me show you once again. When we reach that condition, it means we reach here. It means our n is smaller than the divisor. That's why if we reach this condition, it means the number is lucky number and we simply return true, right? And after this number, what we are simply doing? We are counting how many numbers are remaining. And how to count how many numbers are remaining? So let's say you have number. So let's say you have number 1, 2, 3, 4, 5, 6 and you deleted all the second term. It means 2, 4, 6. How many numbers are remaining now? 6 minus 6 divided by 2. Simple. It means 6 minus 3 and 3. Obviously we are remaining with 3 numbers, 1, 3 and 5. So this is the formula to get the remaining number, right? And after this, what we are doing? We are simply making a recursive call to this function itself. And now we are passing a remaining number and divisor plus 1. Why? Because in step 1 we are passing divisor is equal to 2 and in next step the divisor is going to be 3. That's why we are doing divisor plus 1. Okay. So now let's quickly dry run this code and see how it works. So in case of n equal to 10, we call this function by passing n equal to 10 and divisor is equal to 2. And in the first step itself, it checks if n is divisible by 2 or not, right? And in this case, it is divisible because when we delete all the second element, the 10 gets deleted, right? So here we simply returns false and it means 10 is not a lucky number. Okay, what happens if n is equal to 19? So in case of 19, we call this function first time by passing n is equal to 19 and divisor is equal to 2. So 19 is not divisible by 2. So we skip this step. Then we check divisor is greater than n or not. In case divisor is not greater than n, right? So we also skip this step. So ultimately we are going to delete all the second term here. And by using this formula, we get all the remaining terms. And after getting remaining terms, we again call this function recursively by passing remaining and divisor plus 1. So f of 19 to 2 makes a call to f of 10 and 3 because now the remaining numbers are 10 and our divisor is going to become 3. Now in this function we are going to delete all the third element. Okay. After deleting third element, we are having only 7 elements, right? So this function is going to make a call to f of 7 and 4 because this time we need to delete fourth element. Okay, here we delete all the fourth element and this function makes a call to f of 6 and 5. Now this time we want to delete all the fifth element. Now f of 6, 5 makes a recursive call to f of 5, 6. Now here we want to delete 6th element, but we are only left with 5 elements. So this is our base condition. So we hit the base condition and we simply returns true. Okay. So this last function returns true to its parent. This parent returns true to its parents and so on and so forth. And this way we get our result as true. It means 19 is a lucky number. So far so clear. So now let's move on to time complexity. Okay. As we know that this is a recursive solution, so to get time complexity, we need to count that how many recursive calls are there. So how many recursive calls are there? In case of 10, the recursive calls are almost 0, right? Because in the first step only we got our answer. And in case of 19, how many recursive calls we are making? So it turns out to be square root of 19, that is equal to 4. And it is true. See how many calls are there? 1, 2, 3 and 4. And this is the main function, right? This is the main function call and all these calls are recursive. So we could say that the time complexity of this solution comes out to be big of square root of n, right? Now what about space complexity? So we know that whenever we write recursive functions, we need memory to store all the function calls, right? So how much auxiliary space we need? So it depends upon how many function calls are there. And how many function calls are there? There are 4 function calls. It means we need square root of n stack frames to store all the function calls, right? So it means the space complexity of this function comes out to be big O of square root of n, right? So far so clear. So I hope now you have a good understanding about how to find lucky number. So this is it for this video. Thanks for watching. See you in the next video.